Okay, welcome to the lecture on basic trigonometric identities. This is part one of identities, and we'll have another objective on that next week. The basic trigonometric identities are these. You can download this sheet from Blackboard under week 6. It's posted, and there are a total of 14 identities on the sheet. Now, the good news is that all but 3 of them we have worked with before, at least at some level, although some of them may seem a little bit unfamiliar to you. It's important to also note that we have categories of identities. There's a group called the reciprocal identities, another called the ratio identities, another called the even-odd, and another called the Pythagorean identities. So let me just mention what's on here a little bit, and then in another video I'll actually show some examples of using these. But first I want to make sure you understand what they say. The first 3 of these we've done quite a bit with already, so you probably are familiar with them. The cotangent is the reciprocal of the tangent, the secant is the reciprocal of the cosine, and the cosecant is the reciprocal of the sine. If you remember, we had a standard order of writing these vertically when we first introduced the trig functions: sine, cosine, tangent, cotangent, secant, cosecant, and then we said those nested pairs, the outermost pair being cosecant and sine, are reciprocals of each other. The next pair in secant and cosecant are reciprocals, etc. So that's simply a restatement of what you have seen before. We have done this quite a bit before as well. The tangent is the tangent of x is the sine of x over the cosine of x, and the cotangent of x is cosine of x over sine of x. Now, there are a few more that we haven't worked with too much, though we've said a little bit about especially the one for sine and the one for cosine in the past. But let me just make all that official now by saying that these are known as the even-odd identities, and what we mean is this: if a function is even, then that means f of minus x equals f of x. In other words, if you plug in a number and it's negative, you get the same thing out. And the function x squared, for instance, is an example of that. That's even, because if you square minus 2 or you square plus 2, you get the same result, right? So f of minus 2 and f of 2 are equal. And in fact, this works for any x. It doesn't have to be just 2 and minus 2. So f of minus x is the same as f of x. And that's what we mean when we say that a function is even. We're really drawing the names from the powers of x. The even powers of x are even functions, and the odd powers of x are odd functions. Now, an odd function has this property: f of minus x is minus f of x. So x cubed has that property, and you could check that out by, let's say, well, let's plug in 2 and minus 2 again. If I plugged in 2 here, I'd get 2 cubed is 8. If I plugged in minus 2, I get minus 2 times minus 2 times minus 2. I have 3 negatives. We're going to have 1 negative left over, so I get minus 8. 8 and minus 8. So f of minus 2 is the same as the negative of f of 2. And that's what this notation here means. So that's an odd function, and f of minus x equals f of x. That's an even function. Okay, the even functions in the 6 basic trig functions are the cosine and the secant. Now, the secant, of course, is the reciprocal of the cosine, so it's no accident that if cosine is even, then so is the secant. So, and the short version of all that is this: cosine of minus x equals cosine of x. That you should memorize. The secant of minus x is the secant of x. That's worth memorizing too. Now, all of the other 4 trig functions are odd. They act the other way. Sine of minus x is minus sine of x. So, for instance, sine of pi over 2 is 1, and sine of minus pi over 2 is minus 1. So those differ by a negative, and we have this pattern here. So the odd functions are all but the cosine and the secant in the 6 trig functions. The last set of identities that you really want to be familiar with are these called the Pythagorean identities. Sine squared x plus cosine squared x is equal to 1. And you can get that from the unit circle. If we have a unit circle, so that means a circle centered at the origin with radius of 1, and therefore every point xy on the circle, the x coordinate will be the cosine of theta, y coordinate is the sine of theta, where theta is this this angle here in standard position. So theta would be this angle in here, and we can see that x and y take on those values. Now, what do I mean by the Pythagorean identities just come out of here? Well, suppose that we were to draw in the right triangle like this. Then this is the leg of the triangle, and this is the leg of the triangle. So the x coordinate is this distance right here, and the y coordinate is this distance right here. Well, x squared plus y squared is equal to the radius squared, but it's a unit circle, so that's 1 squared. The x coordinate is cosine of theta. The y coordinate is sine of theta. And 1 squared, of course, is 1. So cosine squared theta plus sine squared theta, or the other way around, sine squared theta plus cosine squared theta is equal to 1. And that's where this first identity comes from in this list. Now, the next two you get by division. If I take sine squared plus cosine squared, sine squared x plus cosine squared x equals 1. So I've got an equation here. There's no reason I can't divide every term by the same thing. So I'm going to divide each of these terms by, say, cosine squared. All right, now sine over cosine is tangent. So this is sine over cosine all squared, or tangent squared. Cosine over cosine is 1, and 1 over cosine is secant, but notice that's squared, so this is secant squared x. So tan squared x plus 1 equals secant squared x. In the same way, we could start with sine squared plus cosine squared equals 1 and divide it through by sine squared instead of cosine squared. Well, sine squared over itself is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. So that gives us the last of the 3 identities. 1 plus cotangent squared x equals cosecant squared x. That's this guy right here. Now, what I do personally is I have this one memorized. And I'm, of course, generally familiar with these, but I know the trick to get from here to here is to divide through either by sine squared or cosine squared, and so I can do it so quickly that in many cases you won't even know that I'm working from this to this in order to generate that identity. I can just usually write it down very, very quickly, even though mentally I'm doing a division process. Now, you should do what works best for you. But I do recommend that you memorize at least this, and then either these two or learn the trick to derive them quickly, because they come up so very frequently. And that really goes for this one here. You certainly are going to need to know that cosine and secant are even and the others are odd. And this sine over cosine or cosine over sine for tangent and cotangent, that's just critical, and these things are so common that if you don't commit them to memory, I fear that you just won't be able to solve the problems because you don't see the patterns that are there. So I strongly recommend that you memorize these identities. Okay, that is a list of the identities. I think if you count them up, you'll find out that there are 14. And I will show you in the next video how to make use of them.